On October 7, 2025, the European Space Agency released what it called the first official image of 3I Atlas, an interstellar object captured as it passed near Mars. The world waited for a revelation. Instead, it got a faint, blurry dot and 4 days of silence from every other major space agency. Why did NASA, China, and the UAE hold their silence, while ESA stood alone explaining chemistry that shouldn't exist? A path too perfect, a coma made almost entirely of carbon dioxide. If this was just another comet, why did every answer lead to more questions? This is the story behind the image that changed everything, the first real glimpse of an interstellar visitor, seen not from Earth, but from the red sands of Mars. The discovery began quietly on October 2, 2025, just after 9 in the morning, local Martian time. A small, wide-field camera aboard NASA's Perseverance rover captured something that wasn't supposed to matter. The camera was called SkyCam, a humble color imager designed to monitor dust, clouds, and the Martian horizon. It wasn't built for astronomy. And yet, while the world waited for orbital telescopes to lock on, SkyCam became the first to detect 3I Atlas near Mars. NASA later published the raw image, a faint green-circled speck barely visible against the pale Martian sky. Daylight on Mars is harsh. Dust scatters sunlight, washing out the faintest cosmic visitors. Most people would have missed the object completely if not for the small circle that marked its place. But one person noticed. Mallory Leifeland, Perseverance's shift lead, insisted the camera keep running even as a U.S. government shutdown threatened to pause the mission. She argued that even a weak capture could prove historic, and she was right. That image, time-stamped 9/18 local Mars time, became the first tangible proof that an interstellar object had entered the Martian system, a photograph from the surface of another planet showing something that came from beyond the stars. The next day, October 3rd, brought an extraordinary alignment. 7 spacecraft, each orbiting Mars from a different angle, were perfectly positioned to study 3I Atlas as it passed just 30 million kilometers away. This was no ordinary flyby. It was a cosmic coincidence, a network of eyes converging for one fleeting moment. Each spacecraft brought something unique. HiRISE on the Mars Reconnaissance Orbiter could capture landscapes sharp enough to reveal rover tracks, but its narrow field made tracking a comet like threading a cosmic needle. CASIS, aboard ExoMars Trace Gas Orbiter, offered flexibility, stacking multiple exposures to trade detail for sensitivity. Themis on Odyssey scanned for heat, though comets are rarely warm enough to glow in infrared. Meanwhile, Mars Express contributed 2 spectrometers, Omega and SPECAM, to dissect the comet's chemistry, searching for traces of carbon dioxide, water, or something far stranger. Nomad, also on the Trace Gas Orbiter, hunted for volatile gases, possible clues to an interstellar origin. China's Tianwen-1 added multispectral and radar imaging, while the UAE's HOPE probe watched the comet's brightness in ultraviolet and optical light. For a few precious hours, Mars became the best observatory in the solar system. On October 7th, ESA finally went public, but instead of a breathtaking portrait, the world got a looping animation, a faint, drifting dot wrapped in a ghostly haze. The footage came from CASIS, pointed exactly where 3I Atlas was expected to pass. According to Nick Thomas, the instrument's principal investigator, the comet was at least 10,000 times dimmer than normal Martian targets. To protect data integrity, exposures were limited to just 5 seconds per frame. The result? Hours of data condensed into a few seconds of motion, showing not the comet's nucleus, but its coma, a fragile shell of gas and dust thousands of kilometers wide. It faded quickly into the noise. its tail invisible, its composition uncertain. ESA labeled the spectroscopic results inconclusive. The raw data and all Level 1 products were sealed under a 6-month embargo. Only the processed animation was released, a placeholder for deeper truths still locked away. Inside ESA, debate raged. The press office wanted a sharper image, a stronger public statement, but Thomas refused. No filters, no exaggerations, no false colors. The risk of misinterpretation, he warned, is too high. And so the world saw only that dim animation, a whisper of an interstellar visitor passing silently by another world. Then came the silence. No data from NASA, nothing from China, nothing from the UAE. On October 4th, days before ESA's release, mission leaders from all 4 agencies met in a confidential teleconference. What they discussed has never been made public. No transcript, no summary, no leaks. But after that call, data sharing stopped. Every agency went quiet. All we have now is a single image, a faint green circled dot in a dusty Martian sky, and 1,000 unanswered questions. Was 3I Atlas truly interstellar, or something else entirely? Scientists continue to analyze the data, searching for isotopes, signatures, anything that might reveal its true nature. Until the embargo lifts, the truth remains hidden, locked away in the archives of the world's space agencies. Perhaps it was just a comet, ordinary and misunderstood. Or perhaps it was something far rarer, a messenger from the deep between stars. For now, all we know is this: that small flickering image changed how we look at the cosmos, a reminder that sometimes the faintest light in the dark carries the greatest mystery of all. It wasn't on any public calendar, no live stream, no transcript, just a private call. 4 agencies, 1 encrypted line. And then, suddenly, silence. For the next 3 days, every spacecraft watching Mars stopped sending updates. No new images, no spectra, no engineering logs. Only the European Space Agency spoke, releasing a cautious animation and a short statement that said almost nothing. NASA blamed the US government shutdown for the blackout, but that excuse didn't explain the silence from Beijing or Abu Dhabi. China's Tianwen-1 and the UAE's Hope probe both went dark too. Inside ESA, tension grew. Communication officers pushed for a dramatic reveal, the kind of announcement that would match public excitement over an interstellar encounter. But the scientists weren't ready. Internal notes warned of premature interpretation and anomalous readings and potential for misdirection. The language sounded less like science and more like crisis management. Memos were rewritten again and again. Every mention of unusual chemistry or unexpected optical effects or non-standard polarization quietly disappeared. In their place came vague promises, phrases like analysis in progress and results under internal review. The silence wasn't just about what was shown, it was about what wasn't. ESA locked away the raw CASIS datasets under its 6-month embargo rule. Even the summary statistics, the polarization curves, the spectroscopic ratios were trimmed to the bare minimum. NASA's Perseverance team released nothing beyond the annotated Skycam frame. All media inquiries were redirected to headquarters. China's Tianwen-1 and the UAE Hope probe both went dark too. The rhythm of science, the constant flow of data, quick-look images, engineering updates came to a stop. Analysts who track interagency behavior noticed the pattern immediately. Space agencies compete, they don't coordinate their silence. The last time this happened, it was during near-Earth asteroid events, cases where early data could cause panic if misinterpreted. But 3I/Atlas wasn't an asteroid. It wasn't a threat. it was supposed to be a comet. So what kind of discovery could make four rival agencies hold their breath? Some believe the silence came from fear of misreading faint signals, or worse, triggering sensational headlines about artificial origins. Others whispered of deeper scientific conflict, disagreements over how to classify the strange chemistry appearing in the first spectral data. The embargo, the redactions, the cautious tone, all of it pointed to one thing. Something in the raw numbers didn't fit. The expectation of open science had collided with the reality of uncertainty. Behind the wall of caution, the data waited for a verdict. When the object passed perihelion on October 29th, the situation became even more bizarre. Even Harvard's Avi Loeb is impressed by the non-gravitational acceleration, trajectory deviations, and findings we're discussing. Let's get to the important stuff first. When Atlas came closest to our star on October 29th, the ALMA telescope made a startling discovery. 4 arcsecs separated the item from its expected location. That may seem insignificant, but it's huge in space. This suggests that there was a force working on Atlas that was greater than the gravitational pull of our stars. And look, this isn't normal for a regular comet. Additionally, the solar observatories Stereo, SOHO, and GEO 19 captured something unprecedented. Atlas brightened in a way never seen before and became bluer than our star itself. This is the 9th official anomaly of this object. But here's the crucial point that could change everything. If Atlas were a natural comet experiencing this acceleration, it would have had to lose at least 15% of its total mass. We're talking about more than 5 billion tons of material that should be floating around it in a gigantic cloud. And here we reach the moment of truth, folks. On December 19th, 2025, just a few weeks away, Atlas will pass closest to Earth. It would be hard to miss that debris cloud if it had indeed shed all that bulk. The 10th anomaly, an item that speeds without losing mass, will appear if this cloud is not discovered. And that, my friends, would be something quite different from what comet physics now understands. Loeb highlights the intriguing fact that studying gravitational lensing phenomena was made possible by our star's close vicinity. In essence, the light from Atlas is bent by the gravity of our stars, which may provide us with further details on its actual makeup. His computation reveals a little but detectable deviation of 0.27 arcsecs. I'm going to give a thorough rundown of what we know about Atlas now for anyone who are new to the channel or who want to remember this amazing tale. Because this isn't just another comet story, it's potentially one of the most important discoveries in human history. Atlas is the third confirmed interstellar object we know of. The others were the famous Oumuamua in 2017 and Comet Borisov in 2019. But Atlas is radically different from anything we've ever seen. First, the size. We're talking about an object that's 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov. To get an idea of the scale, if Oumuamua were a ping-pong ball, Atlas would be the size of a multi-story building. But it's not just the size, it also moves faster than the other two interstellar objects. Statistically, the chance of an object being simultaneously so large and so fast is less than 0.1%. It's like finding a person who's both the tallest and fastest runner in the world. Now, let's go through the 9 anomalies that make Atlas something completely out of the ordinary. First anomaly, impossible trajectory probability. 0.2%. In opposition to the planet's motion, Atlas is traveling in reverse. It wouldn't be so weird on its own. Here's the issue, though. The ecliptic plane of the solar system is within 5 degrees of this trajectory. Consider this. It's similar like shooting a basketball backwards and getting it to go through the hoop precisely in the middle. There is just a 0.2% chance that this will occur spontaneously. The solar jet, the second abnormality, is unprecedented. Atlas created an unprecedented jet aiming straight at our star between July and August of 2025. Comets do exactly the reverse of this. Heat vaporizes the ice on comets as they get closer to our star, resulting in a tail that is always pointing away from it and is propelled by the solar wind. It's basic physics. But Atlas did the opposite. It created an anti-tail pointing toward our star. This defies our understanding of how icy objects behave in space. Third anomaly, size and speed probability is less than 0.1%. As I mentioned, Atlas is gigantic compared to other interstellar objects, but it's also faster. In nature, larger objects tend to move slower due to energy conservation. It's like comparing a truck to a motorcycle. The bigger one is normally slower. Fourth anomaly, perfect timing probability, 0.005%. This is perhaps the most statistically impressive. Atlas arrived at the exact moment to pass within tens of millions of kilometers of Mars, Venus, and Jupiter, while also becoming completely invisible from Earth during its perihelion. Imagine tossing 3 darts at once and striking 3 distinct targets, while a fourth person turns their back at precisely the appropriate time to get a sense of how unlikely this is. The likelihood is 5 in 100,000, or 0.005%. The chance of the fifth abnormality, odd metallic composition, is less than 1%. The nickel-to-iron ratio of Atlas is far higher than that of any known comet, according to spectroscopic investigations. Stranger still, this ratio is similar to the metallic alloys that we manufacture on a large scale in our country. The primordial makeup of the solar system in which natural comets arose is reflected in their distinct metal compositions. This pattern is entirely broken by Atlas. A sixth oddity is the scarcity of water. Very unique. Comets are basically dirty snowballs. Most of their mass is water ice, but Atlas has only 4% water by mass. For comparison, it's like finding an iceberg that's 96% rock. This is so unusual, it challenges our basic definition of what a comet is. Seventh anomaly, extreme negative polarization. Probability less than 1%. When starlight hits Atlas and is reflected, it shows an extreme negative polarization pattern that has never been observed in any other comet, including Borisov, which we know is natural. Polarization is basically how light waves orient themselves. It's as if Atlas is twisting light in a way that no natural materials simply don't do. Eighth anomaly, wow signal direction. Probability 0.6%. Atlas came from a direction that coincides within just 9 degrees with the origin of the famous WOW signal, that mysterious radio signal captured in 1977 that many consider the best evidence of extraterrestrial communication ever detected. In the perspective of interstellar space, 9 degrees may seem like a lot, but it's like 2 automobiles going through the same junction only minutes apart. Impossible blue brilliance is the 9th anomaly, just found. Finally, we reached the latest finding. Atlas got bluer than our star itself and blazed more fiercely than any known comet at perihelion. Using typical cometary materials to illustrate this is physically very challenging. This brings us to what could be the 10th oddity. The non-gravitational acceleration that ALMA measured suggests that Atlas lost a significant quantity of material, more than 5 billion tons, as I mentioned at the outset. The item should be surrounded by a massive cloud of debris if this actually occurred. In December, when it passes closest to Earth, it will be impossible not to detect this cloud if it exists. If the cloud isn't found, we'll have an object that accelerates without losing mass, something that violates our current understanding of comet physics. As you can imagine, All of this is generating enormous controversy in the scientific community. Professor Avi Loeb, who is one of the world's leading authorities in astrophysics and teaches at Harvard, is suggesting we need to seriously consider the possibility that Atlas isn't completely natural. Loeb isn't categorically stating it's aliens. He's being scientifically rigorous. When you have data that doesn't fit existing theories, you need to consider new hypotheses, however extraordinary they may be. When criticized for being overly speculative, Loeb argues that science has always progressed by challenging conventional wisdom. Galileo came under fire for implying that the Earth orbited our star. Because of his theory of relativity, Einstein was criticized. It's intriguing that Loeb is using the scientific approach precisely. After presenting the information and calculating the odds, he states that additional proof is required before a firm judgment can be drawn. The ramifications would be dramatic if Atlas were indeed a technological or artificial being. We're discussing more than simply alien life. We're discussing a highly developed society with the ability to transport items across interstellar space. But even if the final explanation is natural, some new type of object we didn't know about, this would still be a monumental scientific discovery that would expand our understanding of the universe. The next few months will be absolutely crucial for solving this mystery. December observations, when Atlas passes closest to Earth, will give us definitive data on several of these anomalies. If we don't find the expected debris cloud, we'll be facing the 10th anomaly. If we do find it, at least one question will be resolved, but we'll still have 8 other anomalies to explain. Regardless of the outcome, Atlas has already forever changed our perspective on what's possible in the universe. Folks, we're living through a potentially historic moment. Atlas is making us reevaluate our most fundamental beliefs about the universe. Regardless of the ultimate explanation, novel natural phenomena, unidentified technology, or something we haven't even thought of yet. We don't have to wait decades for answers, which is the most intriguing aspect. We will have tangible information in the coming months that may help us unravel at least some of this riddle. What are your thoughts on the entire tale then? Is it extraterrestrial technology, a strange comet, or something else entirely? Post your hypotheses in the comments section. Additionally, December is going to be an incredible month, so if you want to keep up with every development in this story, subscribe to the channel. There's something strange moving through our solar system, a mysterious object racing past the sun. We can't see it anymore, but for months, astronomers have been studying it closely. Its official name is 3I Atlas, the third interstellar object ever discovered. Scientists also call it an interstellar comet because it comes from outside our solar system. In just 4 months, nearly 100 scientific papers have been written about this cosmic visitor. Some of the information we have sounds almost unbelievable, but today we'll sift through what's real, what's theory, and what we truly know about 3I Atlas. Right now, 3I Atlas is at its closest point to the Sun, a phase called perihelion. The peak occurs on October 29th, when the comet passes within 210 million kilometers, or 1.4 astronomical units, of the Sun. 1 AU equals the distance between Earth and the Sun, so 3I Atlas never gets closer than Mars's orbit. At perihelion, the comet experiences its highest temperature, causing frozen gases on its surface to vaporize, a process called sublimation, where solids turn directly into gas without becoming liquid. This process creates the glowing coma, a cloud of gas and dust around the nucleus and the tail, which forms as solar wind pushes that material away. Unfortunately, we can't see the comet's full display because the sun's glare blocks our view from Earth. But once it emerges on the other side, we'll resume direct observation. The story of 3I Atlas began in July 2025 when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, detected it. ATLAS is a network of telescopes in Hawaii, Chile, and South Africa, designed to spot moving objects in the night sky, especially those that could approach Earth. At first, the team thought they'd found a new asteroid, but one thing stood out immediately. It was moving far too fast. Objects within our solar system orbit the Sun, bound by its gravity. The closer an object is to the Sun, the faster it must move to stay in orbit. Earth travels at 30 kilometers per second, while Mercury, closer to the Sun, moves at 48 kilometers per second. 3I Atlas was traveling at an incredible 58 kilometers per second, even though it was still out near Jupiter's orbit, about 4.5 AU from the Sun. That velocity meant it wasn't bound by the Sun's gravity at all. Instead, it was on a hyperbolic trajectory, passing through our solar system once before flying back into interstellar space. That's how it earned the designation 3I, the third interstellar object known, following Oumuamua, 1I, in 2017, and 2I Borisov in 2019. 3I Atlas differs from its predecessors in several ways. Size. It's huge. While Oumuamua measured roughly 400 meters and Borisov about 1 kilometer, Atlas could span 5.6 kilometers across. Speed. It's nearly twice as fast as both earlier interstellar objects. Trajectory. It entered our solar system from a completely different angle, moving sideways through the planetary plane instead from above or below. Our solar system forms a flat disk, called the plane of the ecliptic, where most planets orbit. 3I Atlas approached at just a 3-degree tilt from this plane, an almost perfect alignment. That's an incredible coincidence in three-dimensional space, where an object could have come from any direction. So where did it come from? Astronomers traced its path backward and found that 3I Atlas entered from the direction of the Milky Way's galactic core, a dense, bright region filled with stars. Viewed from above, our solar system sits in one of the Milky Way's outer spiral arms. But when we flip the galaxy sideways, we see that most stars and matter lie in a thin disk, with some objects floating above or below it in a region known as the thick disk. Astronomers believe 3I Atlas originated from this thick disk, a quieter region where objects can remain stable for billions of years. That makes 3I Atlas potentially 7.6 billion years old, almost twice the age of Earth. By tracing its motion over 10 million years, scientists calculated that the closest it ever came to another star was 0.3 light-years, 63,000 AU, meaning it spent eons drifting alone before crossing paths with our Sun. Although Atlas officially discovered it in July 2025, 3I Atlas first appeared in May 2025 in images from NASA's Transiting Exoplanet Survey Satellite, TESS, which scans the sky for distant planets. TESS captured the object as it moved through Jupiter's orbit. Astronomers measured the brightness or flux of 3I Atlas to learn what it's made of. As it approached the Sun, its brightness increased 5-fold, far more than predicted. This meant the object wasn't an asteroid, but a comet, actively forming a bright coma of gas and dust. Two findings made this even stranger. First was the polarization of light, the direction in which sunlight scattered off the dust. Most comets show positive polarization, but 3I Atlas displayed the most extreme negative polarization ever recorded. This means the light reflected back almost directly, implying unusual surface or dust properties never seen before. Second, the comet developed a visible coma while still beyond Jupiter's orbit, over 5 AU from the Sun. Typical comets remain frozen solid until they reach about 3 to 4 AU, where sunlight is strong enough to vaporize ice water. This told scientists that 3I Atlas wasn't primarily made of water ice. Instead, its coma was dominated by carbon dioxide gas, with a CO2 to water ratio of 8:1, the reverse of what we see in comets from our own solar system. If you've ever seen dry ice, you've seen frozen CO2. It sublimes easily, creating a smoky gas cloud. That's exactly what 3I Atlas was doing, subliming CO2 long before reaching the warmer inner system. As it got closer to the Sun, around 1.5 AU, near Mars's orbit, astronomers observed an explosive increase in water vapor, like a giant fire hose spraying into space. The comet was releasing more water than expected, suggesting internal layers of frozen water beneath its CO2-rich surface. Even stranger, the comet's coma contained nickel but no iron, an imbalance rarely seen, since both metals usually form together inside dying stars. The missing iron puzzled astronomers. As the comet approached the Sun, iron did eventually appear, restoring a more normal nickel-to-iron ratio. It's possible that the CO2 jets initially dragged out lighter nickel atoms first, before enough heat liberated the heavier iron. Then came another surprise. Its tail was pointing the wrong way. Normally, solar wind pushes dust and gas away from the Sun, forming a tail that trails behind. But early images of 3I Atlas showed a sun-facing tail. Scientists think that's because at such a great distance, the solar wind wasn't yet strong enough to push material away. Instead, gas built up on the sunlit side, giving the illusion of a reversed tail. By September, as Atlas neared Mars' orbit, it developed a short, fan-shaped tail pointing away from the Sun, the expected orientation. Not all comets grow long, sweeping tails. It depends on composition and proximity. For example, the famous comet Hale-Bopp in 1997 had a spectacular tail because it came much closer to the Sun, at about 0.9 AU. On October 3, 2025, 3I Atlas made its closest pass to any planet, just 0.19 AU from Mars. Luckily, Mars has several cameras both on the surface and in orbit. NASA's Perseverance rover managed to capture faint streaks of the comet in the night sky by stacking multiple 30-second exposures. Meanwhile, the ExoMars orbiter provided a clearer image, though still too distant to distinguish the nucleus from the coma. The best opportunity for a detailed photo would come from NASA's Mars Reconnaissance Orbiter, equipped with a high-resolution telescope. However, due to a U.S. government shutdown at the time, it's unclear whether that observation was ever made or released. For now, the Sun's glare hides 3I Atlas from Earth-based telescopes. It will remain invisible until early December when it reemerges. On December 19th, it will pass 1 AU from Earth's orbit, giving scientists a brief chance to observe how solar heat and radiation have changed its structure and composition. After that, 3I Atlas will continue outward, cooling and slowing as it leaves the inner solar system. But its journey isn't over yet. It still has one close encounter left. On March 16, 2026, the comet will pass within 0.36 AU of Jupiter. NASA's Juno probe, orbiting the gas giant, will likely capture the final images before the object disappears forever into the darkness of interstellar space. By then, 3I Atlas will be growing dimmer and less active, but it will carry new information, altered by its brush with our Sun. Its chemical layers, gases, and dust could tell us not only where it came from, but also how it changed during its brief visit through our solar system. Why 3I Atlas matters. Each interstellar visitor offers a glimpse into other planetary systems, snapshots of materials formed around distant stars billions of years ago. The differences between 3I Atlas, Borisov, and Oumuamua remind us that what we consider normal here may be unusual elsewhere. The extreme negative polarization, the early CO2 activity, the inverted metal ratio, all of these suggest that other star systems form comets with different compositions, temperatures, and histories. Studying 3I Atlas helps us understand not only how our solar system compares to others, but also how material travels across the galaxy. Though we may never trace its exact birthplace, 3I Atlas has already expanded our understanding of what's possible. It shows that even in the vast emptiness between stars, ancient travelers still drift through space, each one carrying a story billions of years in the making. When it vanishes beyond Jupiter's orbit and fades into the void, we'll still be analyzing its data for decades to come. Every question it raises brings us one step closer to understanding how worlds are born, how they evolve, and how our tiny corner of the galaxy fits into the grand, mysterious dance of the universe.